Hi everyone, this is Mrs. GA, and today we're going to talk about kites and trapezoids. So these two are a little bit different than the quadrilaterals we've been covering so far. So let's start with the definition of a kite. So a kite is a quadrilateral with two distinct, meaning different, pairs of congruent and consecutive sides. So remember, consecutive means in a row or next to. So you can see that in this picture, we have QR is congruent to RS, so these are consecutive sides, and then we have PQ is congruent to PS. So here we have two distinct pairs of congruent consecutive sides. So there are four theorems that we can use to show that a quadrilateral is a kite. So the first one, if a quadrilateral is a kite, then its diagonals are perpendicular. So all kites have this feature, so notice here's our diagonals, and they form 90-degree angles where they intersect. Second one, if a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. So that means one or the other. So in this case, I can see that angle Q is congruent to angle S. They are opposite, and you'll notice that angle P is not congruent to angle R. So it's exactly one pair of opposite angles are congruent. The third one, if a quadrilateral is a kite, then one of the diagonals bisects, which remember means cuts in half, the pair of non-congruent angles. So angle P and angle R are the non-congruent angles. So this diagonal is going to bisect those angles, meaning that QPT is going to be congruent to SPT and QRP is going to be congruent to SRP, this one right here. So I'll do little dashes through them. And the last theorem about kites is if a quadrilateral is a kite, then exactly one diagonal bisects the other. So for this one, we can see that in this case, this diagonal is bisecting QS. And I see that because I see two congruent parts. QT is congruent to TS. So we're going to see if we can use these four theorems to help us solve the following problem. Okay, so here we are told that this is a kite. And the first thing we're told is that the measure of angle BAC, which is right here, is 35 degrees. Okay. And we are also told that BCD, so this entire angle, is 44 degrees. So they would like us to find the following angles. First, they want us to find angle ABD. So we can do this using one of our theorems above. We know that our diagonals are perpendicular, which means this is going to be a 90-degree angle right here. And then we can look at this triangle, and we know that using the triangle sum theorem, all three angles should add up to 180. So we can say 35 plus 90 plus angle ABD, which is this angle which we're trying to find, equals 180. So that means that angle ABD equals 55 degrees. Okay, the next thing they would like us to find is the measure of angle DCA. So remember, we were told that this entire angle was 44 degrees. So I'm going to do this from here to here was 44 degrees. And we know that one of the theorems of a kite is that the diagonal will bisect the two non-congruent angles. So we can see here that that means that these two angles must be equal. So we can make the statement that angle BCE is equal to angle DCA, which is what we are asked to find. And since they are equal, we can make the statement that x plus x equals 44 degrees. So x is going to be 22 degrees. So each angle is 22 degrees. Okay, last we are asked to find the measure of angle ABC. So there are a few different ways we can go about this, but I'm going to use this fact. So we know that this total angle is 35. We know that this is our angle bisector. So if this is 35, this is also 35, which makes the total angle 70 if I add them up. So far we have this is 70 and this is 44. We also know that this angle and this angle are going to be congruent. We know the fact that angle ABC is congruent to angle ADC. So remember, all kites have exactly one pair of opposite congruent angles. So since they're both congruent, we can call them X. And then the last fact that we can use is that the angles of a quadrilateral should add up to 360 degrees. So here we have 70 plus, this we'll call X, ABC we'll call X, plus 44, plus ADC we will also call X because they're equal, and they should all add up to 360 degrees. So let's combine like terms. So 2x plus 114 equals 360. So if I subtract 114 from each side, we get 2x equals 246. So that means that x equals 123. And remember, we called x ABC. So that means measure of angle ABC is 123 degrees. Okay, so let's look at example 2 together. So here we are given a kite, and they ask us to find the area of triangle EFG right here. So remember, the area of a triangle can be found by using 1/2 times the base times the height. So here we can call this the base of our triangle, and one of the theorems of a kite tells us that one diagonal bisects the other. So this is going to be this is going to create two congruent parts. So if GI is 5, then IE is also 5. So we actually know that our base is equal to 10, which is 5 plus 5. And then here, all we need to figure out is our height. So this would be the height of our triangle. So luckily, we know that the diagonals are perpendicular, so we have a 90-degree angle. And we can actually use Pythagorean theorem, which is a squared plus b squared equals c squared, to help us find that leg. So here we have 5 squared plus b squared, remember the leg must be a or b, equals 13 squared. So b is going to equal the square root of 13 squared minus 5 squared. So again, I subtracted 5 squared, and then I take the square root of both sides. And here we get b equals 12. So that's going to be the height of our triangle. So the area of that triangle is going to be 1/2 times the base times the height. So the area of that triangle is 60 units squared. Okay, so now we're going to move on to trapezoids. So let's start with the definition of a trapezoid. A quadrilateral with at least one pair of parallel sides is considered a trapezoid. So here you can see that we have a pair of parallel sides. The other pair does not need to be parallel for it to be considered a trapezoid. So there's a more specific type of trapezoid that we work with a lot, and it's called an isosceles trapezoid. So an isosceles trapezoid is a trapezoid with congruent legs. So if you notice from the figure above, we call the parallel sides the bases, and we call the other two sides the legs. So if your legs are congruent, as they are here, this is considered to be an isosceles trapezoid. So an isosceles trapezoid has some special theorems that apply to it. So the first one is, if a quadrilateral is an isosceles trapezoid, then each pair of the base angles are congruent. So here we can see that these two angles would be congruent. We could also make the statement that these two angles would also be congruent. Our second theorem says if a quadrilateral has one pair of congruent base angles, then it is an isosceles trapezoid. So you can see that this is really the converse of the previous statement. So this means that either we can start with the legs being congruent and conclude that the base angles are congruent, or we can go reverse. We can start with base angles that are congruent and we can conclude that the legs are congruent. And last, a trapezoid is considered isosceles if and only if the diagonals are congruent. So if the diagonals are not congruent, then it is definitely not an isosceles trapezoid. So we're going to see if we can use these theorems to help us solve the following problems. So in part A, here I know that this is a trapezoid because I have two parallel lines, and I actually know that this is an isosceles trapezoid as well. So again, we know it's an isosceles trapezoid because we can see that the two legs are congruent. So if the two legs are congruent, that means that the base angles are congruent. So angle X is 82, and so this must also be 82. And then we know that these are going to be the same because it's our other pair of base angles. And then we also know that the 4 should add up to 360. So we can say X plus 82 plus 82 equals 360. So we can say 2x plus 164 equals 360. So 2x equals 196. So if we divide both sides by 2, we get x equals 98. And that is the measure of angle Z. So it's 98 degrees. Okay, in part B, we are told that KM, which is a diagonal, is 7.5, and we are told that NM is 2.6. So they would like us to find the measure of LN. So again, this total is 7.5. And then we know, so I'll highlight that in blue. And then we know that NM is 2.6. And since it is an isosceles trapezoid, and I know that because these two legs are congruent, I know that the two diagonals are going to be congruent, and I can also conclude that JN is going to be congruent to NM, and KN is going to be congruent to NL. So that means if I can find this distance, then I can find this distance, which is what they're asking us to find. So we can use the segment addition postulate here. We know that KM, the total diagonal, is equal to KN plus NM. We know the total is 7.5. We don't know KN yet, but we know that NM is 2.6. So we can conclude that KN equals 4.9. And again, since we know that Kn should be congruent to Ln. That means that Ln is also 4.9. Okay, now we're going to talk about a new feature of a trapezoid. It's called the midsegment. So the midsegment is the segment whose endpoints are the midpoints of the legs, is called the midsegment of a triangle. So I can see that here are my two legs. I see that this is a midpoint because of the two congruent segments. I can see that this is also a midpoint because of the two congruent segments. So since it's connecting the two midpoints, we call it a midsegment. So the trapezoid midsegment theorem tells us that the midsegment of a trapezoid is parallel to its base. So we could say that this is parallel to the base, to each base, and we can say that its length is half the sum of the lengths of the bases. So this tells us to add up the bases, which we do here, and then cut it in half, and that should be the length of your midsegment. So in this first example, we can use that midsegment theorem. Again, we know that xy is a midsegment because x is a midpoint, and I can see that because of the two congruent parts, and so is y. So we know that the midsegment is half the sum of the two bases. So that means that the length of xy is 11.4. So a pretty straightforward problem. Here we are actually given the length of the midsegment. So here our midsegment is 9.8, and we know one base, and then we want to find jm, which is our other base. So I'll call it x. So we still set it up the same way. Our midsegment is going to be half the sum of our bases. So LK plus JM. So we know PQ is 9.8 equals 1/2 times 8.3, which is one base, plus x, which is the other base. So I'm actually going to start by multiplying both sides by 2, just to clear my fraction. So we have 19.6 equals 8.3 plus x, and then if I subtract 8.3 from each side, we get x equals 11.3, which again is what the measurement of JM is. So 11.3 is our answer. Okay, that's all for today's video. Thank you so much for watching.